Okay, this is the Station 3 Coins, Dice, Cards, and Trees. Listed below are all 16 possible outcomes of tossing 4 coins. You know there are 16 possible outcomes because the fundamental counting theorem tells since there are 2 possible outcomes for each coin, 2 times 2 times 2 times 2 is 16. So here I've listed all 16 outcomes. Notice that I've highlighted a few of the outcomes. I've highlighted all the outcomes that have 3 heads. So row 2, row 3, row 5, and row 9 all have 3 heads. So if I wanted to compute the probability for the number of heads, it would be the probability of 3 equals 4 over 16, or 1/4. Also notice that down here at 16 there are no heads, so that's the probability of 0, and the probability of tossing 0 heads is 1 over 16. In order to compute the probability of tossing an even number of heads, you would need to compute the probability of 2, the probability of 4, and also the probability of 0, and add these 3 probabilities up because these are all even numbers. And then the probability for odd, would be the probability of 1 and the probability of 3. So these are the odd ones. Okay, so the first question that you have to solve for this problem involves number 3. It says the probability of the sum of 10 equals. It asks you to find the probability that the sum is 10 when you roll 2 dice. What you have to remember though is in order to roll 2 dice, you have to have an even number of heads. So you need to compute the probability that the number of heads is even. Remember, that's the probability that you have 0 heads plus the probability that you have 2 heads plus the probability that you have 4 heads on your coins. And you have to multiply that probability by the probability of rolling a 10. So in order to get to the dice, remember, you had to have an even number of heads. So you need to compute both of these probabilities, and since they're independent, you need them both to happen. You need to multiply those probabilities. Question number 4 is similar to question number 3, except for this one, you're finding the probability that there's a card worth 10. In order to have a card, then you need to get an odd number of heads. So it's the probability that the number of heads is odd. You multiply that by the probability of choosing a card worth 10. So but when they say a card worth 10, hopefully when you recognize that the jack, queens, and kings are all worth 10. So how many you have 10, the actual cards labeled 10, you also have to include the jack, queens, and queens because they're also worth 10. Okay, so you multiply those 2 probabilities. For the last one here, number 5, it says the probability that you toss 2 heads and 2 tails, given that you obtained a 10 in stage 2. What you need to remember is that these 2 events are independent. Tossing heads does not change or does not have any effect on the probability of drawing a card or tossing die. So you have to remember this relationship for conditional probabilities, that when you are asked to find the probability of A given B, if A and B are independent, well, this just equals the probability of A. So for this problem, you just need to compute the probability that you have 2 heads and 2 tails. And to do that, you can go back and look at our table right here where we have 16 outcomes and how many possible ways are there for getting 2 heads and 2 tails, and it's just that value over 16 for number 3. So hopefully this helps you answer all the questions you may have for station number 3.